Pioneer Takeover. Pioneer and Miss Kimberly Bremer from Ag Inspirations, way over in Wisconsin. Remember, it's World Milk Day, so we're trying to get everybody from around the country and even other people from other parts of the world to celebrate with us. So Kim, thank you for joining us via Zoom to do this interview. I see you drinking your Undeniably Dairy mug, and it's kind of frozen on there. Did you do that on purpose, or you did? Okay.
I do this mug all the time.
Okay, I don't blame you. I love those mugs. So.
And you kept talking about salted.
Okay, Matt, can you hear Kim pretty good?
I can hear Kim just fine. And you were sitting there talking about salted butter, and it made me thirsty, so I had to have some water. She locked up. There she is.
There she is.
Okay.
Can you hear me okay?
I can hear you now, but I couldn't for a second. So.
Oh, okay. I was just telling him.
Kim?
I was just telling him that you were I was just telling him that you were showing salted butter, and it made me thirsty, so I had to get a drink of water.
Okay, well that's fine. So Matt, you're from Pioneer, and we are so thankful that you were here to bring us a report from the field, talk a little bit about our crop, directly correlates into how we care for the cows, which turns into our milk. So that's why Milk Day, World Milk Day is important to you, I'm imagining, right? So
yes, very important. Love our cows.
So today, Matt and I have a great opportunity to talk about, we're talking plants and plant genetics today. We're going to touch on GMOs. We know that that's a hot button issue that people always have questions about, and this is a great opportunity for people to ask questions if they have any. When Matt and I got together and we were just talking earlier today about the different things that we cover, he thought it'd be cool to go out into the field and show everyone some of the different crops that you plant and talk about why we plant the things that we plant, all the decisions that go into it. And at Swiss Lane, you have a really diverse portfolio of things that you plant. So Matt's going to take the time and he can show us some organic seeds that you've planted. We'll go all the way across the board from an organic field to fields that have GMOs planted in them. And talk a lot about the what and the why. So Matt, what's your first field that you're in?
All right, so this is like pretty much a common day for me. I'll jump in my pickup and I will drive from farm to farm, looking at different fields and trying to help them move through what decisions need to come next. So I've been doing this all week, and just wanted to catch a couple of fields that I thought would just be something that we can all learn from and experience, because once we get in the field, we can learn a lot. Even I learn a lot when I'm in the fields. And I thought I'd start something that's a little different with Swiss Lane, is that we this farm has an opportunity where we are actually growing some organic corn, as well as growing some genetic GMO corn, what I would call normal corn. And so I'm actually in an organic field right now as we speak. And sometimes I'm holding my iPad, so I may not have my screen very good. So I'm sorry if that's the case. But I'll have one of the girls hold the camera here in a minute. But so I wanted to show you some things that are going on out here. The reason why we can grow some organic here at Swiss Lane is because one of the things that you need to do to grow organic is have a good supply of manure. And I think Annie has a good supply, and Swiss Lane has a good supply of manure. So that allows us to fertilize these fields well. The other thing is it allows them to do it as they have alfalfa. And alfalfa is a crop that we only reseed a field every 3 or 4 years. So it allows them to do organic after they've harvested out alfalfa for 3 or 4 years. So I'm in one of their fields, but I wanted to point out some of the challenges that exist. And one of the things that we have to watch out for to start off is that in the springtime, we would not want to plant organic seed until we know that the soil is good and warm and everything is ready. And we want that corn to get out of the ground just as fast as we can from a weed control perspective. So one of the things that you can see in this field, and I don't know if you can see it, and I'll try my best, is we hope that we can get the corn up and going before the weeds get too active, because the only method we have to control these weeds is through mechanical control. So when I say mechanical control, that means a tractor driving through the field, cultivating and going between the rows of corn. And we hope that we can get the corn up and going before the weeds get up and going, because if we have too many weeds in the field, we're going to have trouble producing a good crop. So you can see some of the weeds that are out here. I was in some of their other fields. There was some more weeds coming in some of the other fields. That's a little bit concerning to me today, because we've got to get this corn out of the ground. So let's see how far along the corn is. I'm gonna hold the camera and you can get kind of close to where my shovel is. My hope is that we can get this up and going so that we can do something to control the weeds. So let's dig and see if we can find a seed and find out how far along this corn is. So let me. Sometimes it can be a little hard to find the seed. Let's move over a row. Worms, we like worms. Boy, I'm having a little trouble finding the seed here. Let me see if I can find one over here. Huh. Let's go a little further over here. See if we should be able to find them pretty easily.
No pressure, Matt.
Yeah. Kind of crazy, huh? Usually it's pretty easy to find them.
You'll find one.
Well, that makes it even more concerning. But they're here. They're planted. What's concerning, though, is that the weeds are a little bit ahead. And the one thing in my last videos that I showed you was that normal seed that we sell has a seed treatment on it. And that seed treatment protects it from all the things that are out here that can go after that seed. The one thing about organic seed, here's one. I did find one. The one thing about organic seed is that it can't have any seed treatment on it. So just like the baby at the hospital needs protection, blankets and other things the doctor can do for them, this seed has zero protection. So we have to do everything we can to hope that we can get this thing to come up. So what's concerning is this guy is, it's not concerning, it's normal. This guy is just getting started. He's just getting started. And we have some weeds that are ahead of them. So we're going to have to do something to keep the weeds down in order for this to come through, which is going to cost us extra work to keep that seed alive and moving forward. So just some things to here, things that we have to consider. Want to go to the next field?
Hey, Matt, what was the reason that this got planted at Swiss Lane with organic seed versus any of the other seeds available?
We have a local producer that needed, from a consumer's perspective, needed some organic corn. And so they were looking for people that could do it in an efficient way. This is a place that they can do it. And so it's one of the things that they've added to their portfolio. It is cost more work, more acres to produce it, but they're capable of doing it, and it costs more manpower and more equipment to make it work.
Perfect. So are you heading to the next field?
So I'm going to go to the next field, which is a normal production field that they would use for the dairy. and we can do that. And more than happy to take any questions as we go. You got it from here, Kim, until we get to the next field?
Here, I can take it. We're good.
All right.
Okay. A little bit of background. My name is Kim Bremer. I'm from Ag Inspirations. It's a company that I started 5.5 years ago to help bridge the gap between farmers and consumers. And I spend a lot of time talking to farmers about speaking up about agriculture. I also spend a lot of time talking to consumers and licensed healthcare professionals and trying to bring the science from the field, like what you're getting the chance to do today through all the Facebook Live videos that Swiss Lane is doing. So this is a really great opportunity to do this during World Milk Day. One thing that always comes up in questions and topics that people really want to hear about is and about crop practices, conservation practices on farms. And it's great to have Matt with us today because he can actually take us out in the field, share a lot of these things. But when we look at what we're planting and why, I mean, farmers started domesticating crops 10,000 years ago. If you look at corn from 10,000 years ago and it's teosinte and it's like this big, it wouldn't be very useful to any of us. We've come a long way. And, you know, we've gone from crossbreeding plants to interspecies crosses. That has made things like tangelos, to mutagenesis. And, you know, mutagenesis is a really great technology. It's been used for a really long time. Most organic seeds have been improved using mutagenesis. It's where we take chemicals or radiation to alter DNA. It's perfectly safe. There's varieties of rice, of apples, of a number of different things that have been improved using mutagenesis. And then we have the latest technology from the 80s, which is the infamous discussion about GMOs, genetically modified organisms, and what does that even mean? And there's tons of misinformation and fear marketing out there. And it's okay to question where your food comes from and how it's grown and raised. There's nothing wrong with that. Our mission is always to get people to include farmers in that discussion because there's a lot of marketing that goes on in food. And we know that fear is a really powerful emotion. It's 11 times more effectively at selling a point than facts and figures alone. And that's no secret when we look around today in marketing of a number of different things. But what we were going to talk about today and what Annie had asked us to cover as well were some plant genetics and to talk about GMOs and offer a time where if you have questions, you can ask because you should ask them and you should talk to farmers and agronomists like Matt and agriculturists and people who spend a lot of time in this arena. And Matt's going to show you a field that has some GMOs in it, planted in it, and he'll talk a little bit about the differences. But when we look at GMO technology, what does it even mean? It's when you take a gene from one species and put it into another, and it's precise plant breeding. So all the other things, the crossbreeding, the interspecies crosses, the mutagenesis, when we're improving seeds, we're affecting 10,000 to hundreds of thousands of genes. And when we're doing GMO technology, we alter 1 to 4 genes. So it's very precise, precision ag at its finest. And you hear all kinds of crazy things out there. You know, Dr. Oz talking about that there's fish genes in tomatoes. It's not true. There are no GMO tomatoes. We know that there's really only 10 commercially available crops and more cool research coming on the way. So it's in corn, cotton, canola, alfalfa, sugar beets, papaya, squash, soybeans. The 2 latest ones have been the innate potato and the Arctic apple. Now, the Arctic apple has a really cool story. I've actually interviewed Neil Carter. His family, he's from British Columbia. His family developed it. He married into a small orchard there. He has a great story. I wish that the Arctic apple would have been one of the original GMOs. So we could have explained it a little bit better. But or at least in terms that people would understand, because explaining a Roundup Ready soybean to someone and why that's important to farmers, that was a difficult discussion to have early on. But an Arctic apple, one that you can cut and it won't turn brown after it's been cut and it's exposed to oxygen. That's a cool technology. We can save on food waste. Okay, it looks like Matt is back in the field. So we can hear from him next. We'll pick up this discussion. Matt, can you hear me?
I can hear you. I had to put my speaker back on so you could hear me. Can you hear me?
No, it's okay. I didn't want to miss what you're walking through, but we were just going over GMOs and a little bit about what they mean in precise plant breeding. And in your case, you're going to show us some GMO corn, correct?
Yeah. Yep. So one thing I wanted to point out that I didn't point out over there is that in many cases, especially and even here, we use the same genetics that they will use in the organic field, just untreated, no traits. It is the same genetic products that we will use even in the GMO field, just that the GMO fields have the actual traits in them. Does that make sense?
So what are we looking at here? What is it?
So this is another field of corn. I can tell you that this is a cornfield that's intended for silage. Here at the dairy farm, we will, a little bit differently, we'll plant this corn in 22-inch rows, where generally it's 30-inch rows. So I always know when I'm in one of Swiss Lane's dairy fields because the row spacing is closer together. So this row here is only 22 inches from this row here versus 30 inches, which is normal in this area. So we're out here, we're looking at, this is my favorite time of the year. These are baby plants. They're starting to show some interesting things. This time of the year, these plants are, I'm going to show you some things about the plant. These plants are changing their root system. And so they're going from using, I should get on the shovel a little bit can you hold this right here? So this plant looks no different than any other plant. We have our seed.
Hey, Matt,
Yeah.
how many seeds per acre do you plant?
So generally in this area, we'll seed these corn crops from 28 to 35, 36, sometimes even higher, 1,000 plants per acre. So in a normal yard, a quarter of acre, that's how many, you think about what an acre size is. That'd be, if you had quarter acre, you'd have 4 different houses. That'd be 30,000 plants in that area. So that's what we're looking for. And I spent all week looking at fields that had ranging populations. And that's what we were looking at. But something that is really cool, and I don't want to miss it and point out, as we're talking about all these things, I also want to talk a little bit about plant physiology. Is this right here is the baby's root system. So that seed, this is the first root system that comes off of that seed. It only uses that root system until about V2 to V3. And then it puts what they call it's a seminal root system. I call it its permanent or adult root system in general terms. It puts that on. That's our adult root system. So right now, this corn plant's in the process of making that change. And so that's why some of this corn is showing it's a little bit yellow and not quite so green, because it's waiting for those nutrients to come in through that adult root system. So here's a perfectly normal cornfield. The thing that we can do out here is we've got the weeds controlled. This corn has the traits in it for Roundup Ready and Liberty Link. So it allows us to use those herbicides to help us control weeds, as well as BT trait. BT is used all over the world in different situations, but in this case, the BT is allowed to be, or we can put it right into the plant. And so that plant can be protected from a lot of different insects, black cutworm, corn rootworm. So some of the most hurtful pests to corn we can kind of control, but not hurt all the other worms and all the other insects out there. It's just kind of focused on taking control of those specific
Let's
insect.
talk about that for a second, because normally people always ask why. It's an important discussion we have, because I think a lot of people don't realize, you know, every farmer's crops compete with 30,000 species of and 10,000 species of plant-eating bugs, and it's your job as a farmer to protect your crops.
Yep.
All you are, it doesn't matter if you're an organic farmer, a conventional farmer, it really doesn't matter. It's that everyone has these challenges, so it's about all the different tools that are available for the farmers to use.
And the problem with the especially like an insect like black cutworms, if you know, today Swiss Lane is out cutting hay. All their people are out working really hard cutting hay. They don't have time to pay attention to this field here we're in today. And the way that black cutworm works, they're here today, the crop is gone in 2 days. So they can get done harvesting hay, happen to drive by this field, it looked like this today, and it would be gone in 2 days. So that is how impactful these insects can be. And so we have to find ways to control them. And we can do that through BT that's used in a lot of different products, or we could use a insecticide to control it. We have to find ways, no matter what it is, to do it. And finding ways that are more sustainable and more healthy is the way that we try to go.
Wow, BT has an awesome story too. Actually, the #1 approved pesticide used worldwide for use in organic. But it's also available as a GMO, the protein bred into the plant. Because if you don't protect a corn plant, Matt can probably help answer this too. Corn is really resilient and it wants to live. It will do everything it can to protect itself. It's very hardy. So if you have bug pressure, like corn borers, for instance, I mean, I have them in Wisconsin, you have them in Michigan, you're either going to spray that corn crop with corn borers who can wreck your field, or you're going to maybe next year or next time you plant corn, plant BT. Because if you don't, under the right conditions, corn will actually produce its own toxins to help fight off challenges. And then we harvest it with mycotoxins in it. Then we have to feed binders to the animals, because at the end of the day, healthy plants make healthy food, whether
That's exactly right.
people or animals. But BT is a great story. I think most people don't realize BT, the actual spray, the chemical itself, is used on a lot of crops across a lot of different methods of farming worldwide. And it's also available as a GMO.
Yep. So something we widely use. In our case, we use products, Herculex, and different products, but it's a pretty phenomenal trait. So, you know, from a Pioneer perspective, we do a lot with breeding. Breeding is really important. Breeding is a big deal, but also using these traits to help protect these crops is important. The other thing I would point out, and I talked about this in my last one, is you notice the seed on this one, this plant here, you can see that it's got colored, and we talked about it before. It's a seed treatment. This corn was planted almost a month ago, probably more than a month ago, and it had to fight through a lot of different challenges. And just like you said, corn is really resilient and it wants to push through. This corn has been through, I think, even a snow, several inches of rain, and still here it is. Almost every single one of them came off. So we found some pretty awesome ways to keep these crops healthy and keep them moving forward. And that's the stuff that excites me every day, is to see how awesome a job these things do, and how resilient it is. Yeah.
It's also great to talk about the farm conservation strategies. Every farm has farm conservation strategies that they use. And maybe, Matt, you could talk a little bit about like the nutrient management plan at Swiss Lane. What does that mean?
Yeah.
Crop rotation, no-till, those kinds of things.
Yep. So Swiss Lane does a really good job. They do a fair bit of rotating. They have wheat, soybeans, corn, alfalfa in their rotation. So having different crops on the land is a really cool deal. They also do and have in the past done zone till and minimum till, and also do some conventional till. But the minimum till is an example where we just till where the seed row goes, and that's a pretty cool concept. Put the fertilizer and the seeds and the tillage all in just the rows, and then the minimum till is where we just make a pass over and try not to disturb as much of the ecosystem as possible in that soil, and just come in and plant. So a lot of different things that are going on. Another thing that usually they do, and I see that it was working sporadically here and not sporadically, it's some of the technology that we're using. And so that's the hard part with technology. And Kim's dealt with that, a little bit today. Sometimes technology works well and sometimes it doesn't. But we call it row shutoff. And so the planter literally knows when it comes to the end of the row and it will shut off. So you see where there's rows running away from me and then there's rows running the other direction. We use row shutoff. When we get to this cross row, the computer knows to tell it, I'm going to stop planting here, and it'll shut the row units off as it comes across that row. So they use a lot of different technologies on this farm, all of them to make them better and to use as little resources as possible to make the crop as good as they can make it, and also to do it as efficiently as they can.
And that is really the name of the game. Is farmers are always continuing to produce more using fewer resources. This mission of always improving what we're doing. If you would have told my grandpa that someday he'd be able to sit in the tractor with us while it's talking to one of the 26 satellites in space, variable rate applying manure where we want it, or planting seeds in exact rows using auto steer, he would have said, "You're crazy. That'll never happen."
Yeah.
But here we are. It's what we do. It's precision agriculture, and it's continuing to evolve and improve. And the technology involved today is almost unimaginable. It's one of my favorite things that I love thinking about when I get to talk to students everywhere. And I'm sure Annie can relate to this too when she gets all the visitors at the Discovery Center, that I look at all of them and I think, what are they going to invent in their lifetime that I might get to see that we can't even imagine today?
Well, what's crazy is that I started doing this basically same exact job in 2001, and in that time period, I've seen GPS come into play. I've seen GPS get better. I've seen basically tractors, steering themselves. I've seen the row shut off. I've seen population being able to change with the soil, with the computer and the tractor. All these things have happened. And just starting in 2001, that makes it 19 years. What's going to happen in the next 19 years that these guys are going to figure out to do better? And I think the next one that's coming is going to be an autonomous tractor where we literally don't even have somebody in the cab driving it. That's going to be really cool.
Agreed. How about, we talked a little bit about it, but maybe you could talk a little bit more just about using the GMOs in the field. You really don't have to do tillage, correct?
Repeat that question one more time.
So you just were in that cornfield that had Roundup Ready, BT. You really don't have to do any tillage in that field. Compared to the field where we started today, you're going to have to do something about those weeds. So it will likely be tillage. So what's the advantage of not tilling?
So the cool thing is about, and growers are starting to work with it and experiment with it and trying to figure it out, is they're trying to understand, these planters are doing such an awesome job that they can set them up to not even have to till the field. The planter will move what I call the trash, but basically the previous crops, organic matter away from the row so that we can just plant right through that area and not even have to have tilled it. And that's some pretty neat stuff. It takes extra work to do it, but it's we continue to learn more and more every time we do it.
There's also a lot of discussion about carbon, and we store carbon in the soil. So as we start talking about, or we hear more about the carbon footprint of agriculture, you know,
Yep.
every time you move topsoil, you release carbon into the atmosphere. Every time we're tilling, we're releasing carbon from the soil. So anytime we can work to try and not move that, that's beneficial.
So we're going to move a lot of it. We go back to the organic field. We're going to move a lot of soil in that field all the way through the year. And we're going to do it in hot times of the year to keep that corn plant happy and healthy. So in this field here, in this situation, there won't be any more tillage in this field the rest of the year until harvest.
That's cool. That's storing a lot of carbon. I'm pretty sure the last numbers that I saw that got calculated, the use of GMO technology that allows for no tilling worldwide has taken over 64 billion pounds of carbon out of the atmosphere, the same as 15 million cars off the road a year.
Yep.
That's the technology that farmers can use, which is pretty amazing. And it's not to say every acre needs to be no-till. I really hope that people get that part of this discussion from us is there is no one way, one size fits all way to farm, that it's about farmers having tools available to them that can be customized for their acres. Because I mean, Matt, what are we dealing with? 20,000 different soil types, different weather zones, 13 different hardiness zones nationwide. I mean, there is what works in one place doesn't work everywhere. What works in one field doesn't work everywhere. What works for one farm doesn't work everywhere.
And I learned a lot about that because I lived in Ohio for 10 years and worked down there. So I had the opportunity to witness different growers' operations and how they do things, and moving here to West Michigan where Swiss Lane is, and how growers will incredibly adapt to the environment they're in, and make the same thing happen here that's happening down there, but do it entirely differently. And that's really cool to watch.
It is. I think farmers in particular are some of the most, I would say, creative problem solvers that there are.
And resilient. It's a word I would use.
Yes, that's a great word, especially right now, resilient.
Yep.
We have some questions coming in. Okay, talking about GMOs. Yes, I get this. I do get these questions. So there is always this concern about safety because there's fear marketing out there. They're not the easiest thing to understand. We're talking about food, which is very personal and close to all of us. So how do we know that they're safe? Or I don't think that they're safe. This person's asking about allergies. They cause allergies. So what we can tell you is that on average, it takes over a decade for the approval process to even get one to the market. And I tell the story all the time that I wish that companies would talk about, or at least even, I don't care, put out a press release or a commercial, talk about the GMOs that never make it to market, because we never hear about them. And there are great stories behind all of them. And I think if people understood what it takes to bring them to market, they'd be maybe less fearful, because the approval process in the US is big. They also have to be approved worldwide because of trade. So there's over 90 agencies worldwide that have to approve them.
That's right. Every country has to approve them.
Yes, and there's 70 countries that plant them worldwide. So they have this really strict process that they have to go through, and they have to show that they are equally as safe as their conventional counterparts. I love telling the example of the soybean. There was a company doing research on a soybean that was higher in protein using a gene from a Brazil nut. Now remember, GMOs only affect 1 to 4 genes. It's precise plant breeding. So they wanted to take the gene from the Brazil nut, because it's higher in protein than a soybean, put it into the soybean, make a higher protein soybean, which would be great. We would have higher protein edamame for people, We'd have higher protein soybean byproducts to feed our livestock, so you'd have to feed less of them. So there'd be tons of benefits all the way around for this. Yet 7 years into the process, the entire project got scrapped, millions of dollars in as well. And what was the reason? Did it ever get commercially made? Did anyone ever eat it? No. But what happened was the company was uncomfortable with how much it changed in comparison to its parent plants. And especially when we're talking about protein, because most food allergies occur from the protein fraction of a plant. And they did not like how much it changed from the parent plants. They scrapped the whole project. It never even got close to anyone. They couldn't prove that it would cause a food allergy. No one was ever made sick. But it was just the idea that food safety will be an issue, and we don't want allergen responses in terms of GMOs. So I really wish that the companies would come out and talk about the ones that don't make it and why, because it may add some trust to the system. Because from the outside looking in, if you're not in agriculture, it looks like everything that we're working on always gets approved. And that just simply is not the case.
I mean,
people say all the time, oh, I wish that it was like in the EU, because they're banned in the EU. Well, that's not entirely true. They don't allow the farmers to plant them, but they import them all from us. They approve them all for safety, and they import them from us. They feed them to their cattle, their livestock, their people. They just don't allow their farmers to plant them. Their system, their agricultural system is much different than ours, but just different perspective.
I think you would find many other countries that even Corteva and other companies have taken these traits to where they were having trouble producing food and help them create a sustainable food system because we brought the traits to them, and they're extremely thankful and less hungry than they were before. So obviously, from a Corteva perspective, for us, it's about the people, the community, and it's about helping our farmers and everybody live a better life. And so this is what we do. And we work hard to make sure that people are safe.
Yeah, and advantages to people. We talked about that a little bit in the beginning, but it'd be interesting. I wonder if this discussion would be different if instead of the first GMO being a Roundup Ready soybean, which was developed by a company for farmers. That company today will tell you that they never in a million years dreamed that an average everyday consumer who wasn't farming would care about this technology. That they didn't market it to people. It was marketed to farmers. What if it had been, let's say, the Arctic apple that won't brown when you cut it, and we could reduce food waste? Or what if it would be, our next GMO that will likely be approved is wheat for people with celiac disease. So a gluten-free wheat. I have a celiac kid in my house, so that would be awesome. They're working on solutions for the orange groves. We've lost over half of the orange groves in the United States because of citrus greening fungus. They've isolated a gene out of spinach that could likely save it. It's just, can they get it to work and get it approved in time? I don't know. They're working on allergen-free peanuts. Also, big consumer benefits for people. It's just if we can get the technology accepted enough by people, and if there's companies willing to invest.
One of the things that we made, and something that we use is Plenish. We made what's called Plenish high oleic soybeans that we grow, 20% less saturated fat than commodity soy oil. So, cool things that we're being able to do with these genetics just to make things even better.
Yeah, consumer benefits for everyone. Yeah, so healthier oil profile in soybeans. Cassava, if you've ever seen it, it looks like twigs, sticks. It's a major food staple in poor countries around the world, and they're using the technology to make it more nutritious than what it is. So the possibilities are so endless. It's just keeping the discussion rolling and continuing to ask the questions and understanding what we're doing to try and protect people at the same time. Looking to see what else we had come in.
Hey, Kim, while you're looking for other questions, why shouldn't you tell a secret on a farm?
Is this a joke, Matt?
It's a really lame one, but I had to tell it because, we're just having fun, right?
Okay.
Just having a good time.
Why don't you tell a secret on a farm? I don't know.
Because the corn have ears.
Perfect. Everyone really enjoyed that. Oh, I can't believe that we didn't bring this up. I'm from Wisconsin. I'm a cheese head.
Oh my gosh, cheese.
I'm coming to you from Clark County, Wisconsin. It's the largest geographical county in the state. And I have 66,000 dairy cows here and 32,000 people in my whole county. 2-to-1 cows to people. There's one stoplight in my whole county. It doesn't even need to be here. But anyway, cheese. Without this technology, there would be no cheese like we know it today. So rennet is the enzyme that separates the curd from the whey when we're making cheese and milk. Originated from within calf stomachs. Well, we're not going to slaughterhouse floors and harvesting rennet out of anything there. What we're doing is we are growing all the agrobacteria in the lab. Now we can have all kinds of cheese. There's one form of rennet that is a vegetarian rennet, but it doesn't work with all the different cheese cultures. So we wouldn't be able to have all the cheese varieties that we have today, but all the rennet, that enzyme that separates the curd from the whey to make cheese, is mostly GMO. Pretty cool, huh?
There you go.
And insulin, that's the other big one. Big application of this technology.
How many people use insulin around the world?
A lot.
A lot.
Because my computer is just finally working, so we could do this. I can't Google it, but maybe you could, Matt, but I don't know how many it is. But I know in the early 50s, it took 10,000 pounds of pig pancreases to make 1 pound of insulin. And today, all the insulin that we're making is grown in an agrobacterium in a lab using GMO technology. So this isn't just in crops and plants. It's used in medicine. It's used in other foods. Are you looking? How many people?
I'm working at. I'm trying to get to it.
Oh, I think that they're scary. Yeah, I understand why people would think that, because there is so much misinformation out there. But the story I always love to tell people about that is, and we touched on the Roundup Ready gene today. So I'm sure you know this, Matt, but a lot of people don't realize that where did the gene come from to make things Roundup Ready?
Oh boy, actually, you might stump me on this one.
When I say it, you'll know. All proof of concept for the Roundup Ready gene was done in a petunia.
Oh, yep. You're right.
Petunias
I remember now. Yep.
I haven't had anyone yet who tells me that petunias are super scary, but that is where the Roundup Ready gene originated from.
So approximately 7.4 million Americans with diabetes use one or more forms of insulin.
That's awesome. See, technology and innovation at its finest, used in medicine, used in agriculture. Love it. I don't see any more questions coming in. Where is Annie? I don't see her at the top of our screen. Otherwise, we're going to move to more jokes if she doesn't have any.
Yeah, please don't. No more Matt jokes. Kim, you were fine. I loved hearing about the rennet and all that stuff. Matt, what on earth? I leave for a few minutes and you're like, dad joke. Like, you know what? I can't make too much fun of you because I have been like very honey as the day has went on. It was like, we gotta move, guys. And they're like, oh, yeah,
okay, wait.
so.
I forgot. I had a couple things. So one.
Oh.
We can't
She
show
has pictures.
No, I don't have pictures, but I ran this off.
Oh, move really slow. We couldn't hear you.
Okay, so I had two quick things to end with. One, if people have questions about plant breeding, GMOs, obviously you can get a hold of Matt. He's the agronomist, and he'll give you his number. Otherwise, I have a list of websites. If you can see it.
Get it closer. 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 Move it over. Up, 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 up.
You see
Now
it?
up.
Up.
Oh, this isn't going to work on here.
Oh, you're kind of there. GMOanswers.com. Something government, feed your mind.
Yeah.
Biofortified.org. Here, I'll read them. Fieldtomarket.org. How about this? We'll get the list to Annie, and if anyone is interested, she can pass it out. How's that?
Well, yeah, I was wondering if we could even put it in the comments on this video.
Perfect. Yep, we'll do that.
So that's an idea.
Is everyone's been home watching Netflix and Hulu and documentaries, and we know there's all kinds of shockumentaries that have to do with agriculture.
At our house, it's been Disney.
Oh yeah, and I'm not saying you shouldn't watch them all, but if you're going to watch them and you're watching any about food, you need to add food evolution to your list. You have to watch the food evolution documentary. It's on Hulu, iTunes, Amazon.
And what is that on?
It's on Hulu.
It's on Amazon Prime?
Yep, Amazon, Hulu, and iTunes.
Okay, I have Hulu.
Yeah, you need to watch it. Anyone who is interested in GMOs, all sides of the issue are presented in it, and I know everyone loves watching documentaries, so make sure you add that one to your list.
Yeah, so just to bring up a hot topic, because that's what we do here today, right? Why not? So my sister is in infection control, and one of the things that just kind of triggers her is like the anti-vaxxers. And so I don't know if you guys saw that video Plandemic, that it was all like, everybody was so upset, like it got taken down and conspiracy theory and so when my sister saw that video, she was like, that is just like an anti-vaxxer, like spewing a bunch of like half-truths. And I said, is the Plandemic movie to you as like Food Inc. would be to me? So, and she was like, exactly. She's like, it's just like so close to the truth that it kind of like distorts it. Can you guys talk a little bit about, I mean, you brought up documentaries. I don't know if what I'm saying rings true to you guys too, but how did what I just say hit you? You can just right or wrong, let's hear what you have to say. Did you watch that movie or the video?
Matt, did you watch it?
I think I did watch it. I saw a couple of videos that they pulled down. I think one of the major things, I guess, that I would say about everything we've talked about here is there are farmers all over the world. There are neighbors. You run into them everywhere. Ask them why they do what they do, and they will have an answer for you, or they'll give you some sort of answer. And they've been feeding their families for years. And one of the things that I shared was actually, Annie, I'll put it back in your play. How old was your grandpa when he died?
He was he was 92 and a half.
And he just died just of recent. We just lost him just of recently. And that's really cool. He's 90 some years old.
I'm tired and you're gonna make me cry.
He's worked in agriculture all of these years. All he wanted to do was make people healthy, right? It's awesome. Mm-hmm. Thank you for your family.
Yeah, I'm not crying. You're crying. The big hole. Big hole right in the middle of our farm. My grandparents' house is sits right in the center of this property. And so, anyway, I am tired. It's been a long day. So anyway, Matt.
All right.
Your check's not going to be in the mail.
So,
cool.
Any last thoughts, you guys, as we close? I mean, I bet you have lots more World Milk Day events that you're going to be attending.
None is fun. Annie?
Okay.
None is.
Just for one last plea, I know there's probably tons of people out there watching right now who could help me with this. We were trying to find somebody who would Zoom us in the like 11 o'clock Eastern Standard Time, who would do like a Zoom call and have some sort of musical guest. I was thinking like Luke Bryan or something, because he does those farm tours, and we're talking about farm tours. So do you guys want to just shoot out a little message to him and have him join us in the 11 o'clock hour, the last hour of World Milk Day?
I'm glad that that's where that question was going, because I got a little nervous. I was thinking, if I got to bust out my guitar, I might have to have a couple of whiskeys and.
You have a guitar? Wait a second. You have a guitar?
Oh boy.
No.
Oh.
Nope.
I'm joking.
Matt, guitar?
I'm a campfire player, but I'm not
You-
playing at 11.
You don't want to see me play any instrument. It's bad, bad, bad. I grew up learning about plants, not
Okay.
playing instruments.
I see. Fair enough.
And-
But
And
just,
telling jokes.
We'll
And
shoot.
telling jokes.
We'll shoot a message to Luke Bryan for you and see if we can get
thank
him.
you. Yeah, start a petition.